Hi, welcome to my channel. This video is a continuation of a series of videos on the Arduino Uno prototyping board. This video covers some basic breadboard prototyping techniques and electronics terminology and theory. We'll be using the Arduino plus 5 volt DC regulator to supply 5 volts to a couple of basic circuits that we will assemble on the solderless Arduino breadboard. I'll briefly talk about breadboarding, resistors, LEDs, and series and parallel circuit concepts. So no programming in this video, but we need to go over the basics of breadboarding techniques, terminologies, so we can build more complex circuits later on that the microcontroller will utilize with programming. So let's get started on breadboarding some basic circuits. So here we have the Arduino prototyping platform. We have the Arduino Uno on the left, and we have the breadboard that will help us assemble our circuits without solder. So here are some of the basic components we'll start using in this video. We have an LED, which is short for light emitting diode, a resistor, and we have some small switches, momentary switches, that when you press them will close the circuit or complete the circuit. We have a couple of those. And of course, breadboarding wires. These are pre-cut wires that the ends have been stripped off so they can be pressed into the breadboard. Usually have different lengths to make it easy to connect your circuits. Now the breadboard allows you to connect your components and your power. You have here along the side sort of like a rail. All these pins and this long column here are all connected together. So this is labeled red plus. So if you go and measure with a meter, you will see that these are all connected together. The minus are all connected together, but these two are separate. These two columns are separate from each other. On the other side, though, these rows are all connected together, but the columns are all separate. So to reinforce that idea, I have a meter here that I have set to check for continuity. That just means that it can measure, it'll give an audible tone if something is electrically connected. So I have the two separate wires here, and you can see when I touch them, the meter puts out a beep saying, okay, these are electrically connected or shorted together. So if we look on this breadboard here, real quick, we will see on the plus, we'll check the plus out, put that in there, that these are all connected down this column here. We can even go to the other end, as long as we stay in that column. But this column here is not connected, only this long row here, or long column. There's nothing else on this board connected to that column. Same goes for if we go over to the negative here, or the one that's marked negative. It'll only be whatever you connect to it, even though they've pre-labeled it. So now let's go look at the other section of the breadboard here, these rows, and you will see that these pins are all connected, but they're not connected to these other rows here. They're all across. And then this, it's a duplicate or a mirror image on the other side with the exact same concept. So this allows you to plug in chips, so each individual pin is accessible with a wire. You can jump. These are also called jumper wires, breadboarding wires, and they're solid. They're not wires that are stranded. It's a solid wire. So with these wires and components and the use of a voltage supply, in this case the 5 volts we will be using will be from the 5-volt regulator on the Arduino, we can breadboard or assemble some circuits and have the Arduino interact with those. But in this case, we will just be assembling a circuit that will use the 5 volts. There's no programming involved in this video. So no programming. We just go over some basic breadboarding techniques so we can build more complex circuits later on that the microcontroller will utilize with programming. But for now, we'll just build a simple circuit and power it up with the 5-volt regulator on the Arduino. So let's go ahead and start that. So along this left-hand side of the Arduino, along this female header here, is where all the power connections are, including the 5 volts from the 5-volt regulator. You can see there. Now this isn't giving us 5 volts on its own. The 5-volt regulator maintains 5 volts for us. It has a certain acceptable range of voltages that it takes in, and it'll maintain or try to maintain 5 volts on the output. But it gets its voltage on the input right now we'll be getting it from the USB port. Right here. So I've inserted 2 wires in the 5 volts and the ground connections on the female header there. We'll plug in the USB port, and you can see the 5 volts here on the meter. And that's what we will use to supply power to our circuit in this particular video. When you initially breadboard any circuits, you do not want to have power on. So you want to disconnect and make sure all the power is disconnected. Whether you have a USB cable connected up to supply power, or whether you have a separate 9-volt battery or a transformer hooked up to this plug here, power plug. So here's a schematic of the basic circuit that we're going to breadboard. We're going to have our 5 volts. V is for volts. We have a 220 ohm resistor. That's the symbol for a resistor. And this represents the amount of resistance to the flow of electricity through here. This is the symbol for an LED. And the LED has a polarity, meaning it has a certain way it plugs into, or a certain direction that it plugs into a circuit. There is a plus side and a negative side. Usually if you look at it from the leaded side, you'll have a flat spot on the LED on the package itself, and that is usually the cathode pin closest to that flat spot. Also, one lead can be longer, and the longer lead is the positive lead, the anode, also called the anode. So the shorter lead will go toward the ground, and the longer lead will go to the plus side. Also, you can see a polarity here. So let's go ahead and breadboard this circuit up. So the first thing I want to do is to connect a wire from the 5 volts, from the 5 volt regulator to the 5 volts on the breadboard, or what we will use as the 5 volts. And it can go anywhere along this column here. I'll put it right down at the bottom here. And right next to that pin is the ground pin. And we'll put that on this side here, marked negative. And that will be our access to the breadboard for the 5 volts and the ground. Next, we have a 220 ohm resistor that goes from 5 volts. And we'll just choose a location here. Press that in. Here we have our resistor. So I changed the position of the resistor. That's the thing about the breadboard. You can manipulate, change, clean up. You know, if you don't like the way it looks the first time or how the layout is, you can change it pretty easily. So from the resistor, we have the LED, and we want the anode connected, the longer lead connected to the resistor. And we now need to complete the circuit by connecting the cathode to the ground with a negative here. And that's our circuit. So before you hook anything up, just review, make sure the connections are the way they should be. There's nothing shorted. So we can now go ahead and hook up our USB cable. And there the LED is lit. The reason the LED on the board is blinking is we're still running that blink program. The blink program is still on the microprocessor chip from the previous video. But you can see there, LED is lit. Now the resistor is limiting the amount of current flowing through the LED. If we did not have that resistor, there would be too much electricity flowing through that LED and it would burn out. So let's add a new component to this basic circuit. We'll add a switch. So we'll still have the basic circuit that we started with the resistor, but now we will have a switch. And this switch will normally be open, so you need to press the button to close those contacts. To complete the circuit. So we'll add that switch now. Now this is called a series circuit. All these components are in series, one right after another. We have the resistor, we have the switch, and we have the LED. And what that also means is that the current flowing through this resistor is the same as the current that will flow through the switch. It'll also flow through the LED. Again, before we do any breadboarding, we want to disconnect the power. Here is the switch we will be adding. Just have to determine which two leads are connected when this button is pressed. So with the help of this continuity measurement here, this helps me figure out how to orient this. You can see when I press, these two leads are connected. So we need to make some changes. I'll remove this jumper wire here, the LED, and we'll insert the switch. Make sure we position it right. The anode, or the longer lead of the LED, goes to the other side of the switch. And then again we have the wire to ground, or the negative side here. And this LED will only light when this button is pressed or closed. So let's go ahead and hook up the USB cable. And you can see it is not, LED is not lit. So let's press the button. There we go. We close the circuit, or we complete the circuit when we press this switch down. Pretty basic, but there are still a lot of concepts involved here. Now let's go ahead and add a second switch. So the only time the LED will light up in this situation is when both switches are pressed. Because if only one switch is closed, the circuit is still not completed. It is only completed when both switches are closed or pressed. So I've already gone ahead and assembled that circuit. Let's hook up the USB cable. You can see here it is off. The LED is off. And if we press any one of these by itself, nothing happens. But if we press both of them together, the LED lights up. Now this might seem pretty simple, but say there were two conditions, environmental conditions you were monitoring. One could be temperature with a temperature sensor, another one could be humidity, a humidity sensor, and you didn't care, there was a certain range or a certain value that you cared about. Well, you could, instead of these switches, you could have this information going to the microcontroller, And when both of these situations, say you had picked a certain humidity value and a certain temperature value, when they hit a certain range, you wanted the microcontroller to monitor those situations and then turn on a fan. So you could build upon this concept where you have you're looking at two occurrences to happen, and when they are both happening at the same time, you want the microcontroller to react. And that functionality you will add with programming and sensors. So you have to start here with this concept, and you can build upon that. And again, all these components are in series. You have the resistor, followed by switch number 1, followed by switch number 2, and then the diode. So now let's change this up again with this circuit. We'll introduce the concept of parallel. So these two switches on the previous circuit were in series. These two switches will be in parallel. In this circuit, both of these switches needed to be closed or pressed at the same time in order to get the LED light. In this switch, the current has two separate branches that it can flow through in order to light this LED. It can go through switch number 1 or switch number 2, or both. So you can switch just one by itself and it'll complete the circuit, or you can use switch number 2 by itself and complete the circuit, or you press both of them at the same time. You will not see any difference. You'll just have current flowing through this path and this path to combine and then still light the LED. So let's take a look at that circuit real quick. So here's the circuit with the switches in parallel, and you can see either this one lights up when pressed or this one, and if you press both, you have current. So parallel, you just have branching circuits. You have different paths that the current can flow through, whereas in series you have one single path that the current is going to flow through. So that's it for this video. I hope I've helped you understand some basic concepts here and some of the skills necessary with starting to breadboard your circuits that you will be putting together. And on the programming side, we will use the microcontroller to control those circuits or read information from the circuits. So we've gone over some of the basics of electronics, some of the basic components, switches, resistors, LEDs, concept of series and parallel, and breadboarding techniques using a breadboard with the breadboarding wires or bus wires. And from here we'll go on to more complex techniques, circuit building and programming together. So thanks for watching. Feel free to comment and or subscribe. Thanks again.